Hey everyone, welcome back to the channel. My name is John and this is your Modern Tech Breakdown. Today I'm covering the latest LLM announcement from Meta. Fair warning, we're going in a little deep today, but let's jump into it. All right, first up, let's talk about what a compiler is. A compiler takes code written in a human readable format and converts it to a computer executable format. This is very much not a simple task. Compilers, in my opinion, are some of the most advanced pieces of software on the planet. What they do is very complex and very important for software developers. Generally speaking, code can't run in human readable forms. It must be compiled in order for a machine to execute it and to be useful. Again, a compiler converts code written by a human into code that a computer can execute. Okay, so given this definition, you might assume that it is very important for a developer to have confidence and understanding of how that code gets transformed. That process needs to be understandable and very, very predictable. There's not much room for interpretation, no pun intended. The compile code needs to do exactly what the written code says. Compilers do optimize code, there's clever techniques, but at the end of the execution, the code comes to the same result every time. Okay, with this in mind, let's look at what Meta released today. All right, so here we have an article from VentureBeat. Meta's LLM Compiler is the latest AI breakthrough to change the way we code. I like the author here saying we code. I guess this author's a developer. Interesting. Yeah. So here, I'll read. Meta has unveiled the Meta Large Language Model Compiler, a suite of robust open source models designed to optimize code and revolutionize compiler design. This innovation has the potential to transform the way developers approach code optimization, making it faster, more efficient, and cost effective. Great. Sounds wonderful, right? So what exactly can these tools do? If we scroll down a little bit, here we are. LLM Compiler achieves remarkable results in code size optimization. The model reached 77% of the optimizing potential of an auto-tuning search in tests, a result that could significantly reduce compilation times and improve code efficiency across applications. And then further, the model's capability in disassembly proves even more impressive. LLM Compiler demonstrated a 45% success rate in round-trip disassembly with 14% exact matches when converting x86, 64, and ARM assembly back into LLVM intermediate representation. This ability could prove invaluable for reverse engineering tasks and legacy code maintenance. Okay. So they've made two claims about what this model can do. First, they claim that the model can optimize the size of the code. As I mentioned earlier, compilers do optimize the human readable code and can take out unnecessary steps in the code. However, they have to be very careful about this, and they have to do it in a very prescribed manner to ensure that the end result of the computation is the same as what was written. If we've learned anything over the last year, it's that large language models are not very careful or prescribed in how they operate. There's all kinds of hallucinations or bad information being generated by these tools. How would you feel as a developer that wrote some code that turned out to be buggy, only to learn that the bug was created by the AI in the compiler? I, for one, would not be too happy. Furthermore, as a developer, it's difficult enough to write bug-free code. I don't need one of the tools in my tool chain to potentially adding bugs behind my back. And by the way, trying to find bugs in the machine code that don't exist in the human readable code is an absolute nightmare scenario. No, thank you. Not interested.
No, thank you.
All right. The second claim is that the model can disassemble machine code. Great. But guess what? We already have disassemblers. I'm not sure why we would want to use an AI model to do a worse job at disassembly. And disassembly isn't a super common use case anyways. Mainly hackers, low-level code optimizers, and developers supporting systems with the missing source code have to resort to disassemblers. There are uses, but I wouldn't call disassembly a common need for the majority of developers. Okay, so what's the takeaway? Some folks at Meta did some interesting research on LLMs using human readable and machine code. That's great. Very cool. However, these tools are not going to be used in the future. There is way too much potential for waste and aggravation for developers. It's possible that new compiler optimization techniques come out of this research. Maybe these models find a new way to do it, and that could be built into the compiler. But I don't ever see a day when a developer will be happy to include an LLM as an optimizer between the human readable code and the machine code. But that's just one guy's opinion. So, all right, that about wraps it up for this topic. As always, thanks for watching. Please like, comment, and subscribe, and I'll catch you next time.